If you have ever sat in front of your computer watching a Windows update install, silently hoping that everything still works when it finishes, you already understand the problem that Microsoft is finally trying to solve properly. Bad updates happen. Driver regressions happen. A script that your IT department pushed out quietly breaks something important and nobody notices until 3 hours later when half the office can't log in. An application update corrupts a configuration file and suddenly software you rely on every day refuses to open. These are not edge cases or rare disasters. They are the ordinary recurring frustrations of running Windows in the real world. And the tools Microsoft has historically provided to deal with them have been, to put it charitably, inconsistent. System Restore has been sitting inside Windows in roughly the same form since Windows Me launched in the year 2000. And while it has saved countless machines over the decades, it was never designed for the complexity of modern Windows installations, the size of modern applications, or the speed at which modern businesses need to recover from system failures. That is what makes the arrival of point-in-time restore in Windows 11 genuinely significant. This is not a cosmetic update or a rebrand. It is a complete new build from Microsoft, designed from the ground up to replace the aging System Restore framework with something that actually matches the way people use computers today. Point-in-time restore is built around a straightforward but powerful idea. Instead of waiting for something to go wrong and then scrambling to find a recovery option, the system works continuously in the background, automatically capturing comprehensive snapshots of your machine on a regular schedule. By default, it captures a new restore point every 24 hours, which means that at almost any given moment, if something goes wrong on your machine, you have a recent snapshot waiting for you that reflects what your system looked like before the problem occurred. You do not need to remember to create a backup. You do not need to set anything up manually before running a potentially risky update. The system is doing it for you on a schedule, quietly, without interrupting what you're working on, so that when you need it, the safety net is already there. What exactly does one of these restore points actually capture? This is where point-in-time restore distinguishes itself most clearly from its predecessor. When Microsoft talks about what gets saved, they are talking about a genuinely comprehensive snapshot of your system state. That includes the operating system itself, so the core Windows installation and all its components. It includes installed applications, meaning the programs you have added to the machine are part of the restored state and not just the underlying OS. It includes system and application configurations, which is critically important because so many real-world problems stem not from corrupted files, but from settings that got changed in ways that break functionality. It includes your personal settings and preferences, and it includes local user files on the machine. The result is that when you restore from a point-in-time snapshot, you are not just rolling back the operating system while leaving everything else in whatever broken state it ended up in. You are rolling the entire machine back to a coherent, working state that existed at a specific moment in time, with your applications, your configurations, your settings, and your files all restored together. That comprehensiveness is exactly what made the old System Restore approach feel inadequate for so many real problems. System Restore was designed to protect system files and the registry, and it did that reasonably well, but it was never designed to capture the full picture of what makes a machine work the way a specific user or organization needs it to work. If a bad application update changed something in a configuration file that System Restore wasn't tracking, rolling back through System Restore wouldn't fix it. If a driver regression corrupted something that System Restore considered outside its scope, you were on your own. Point-in-time restore is built to close those gaps by capturing a much wider set of what makes your system functional, not just the narrow slice that legacy System Restore was designed to protect. Under the hood, point-in-time restore uses the same volume shadow copy service that System Restore has always relied on. This is the technology built into Windows that allows the system to take a snapshot of a volume at a specific point in time, capturing the state of all the files on that volume in a way that doesn't interrupt whatever else the machine is doing. And what Microsoft has done is build a much more sophisticated management and recovery layer on top of that existing infrastructure. The volume shadow copy service still does the underlying work of capturing the snapshots, but everything around it, the scheduling, the configuration options, the integration with Windows settings, and especially the recovery path, has been rebuilt from scratch to take advantage of modern Windows PC management capabilities and to integrate with the Windows recovery environment in ways that the old System Restore framework never did. That last part matters a great deal in practice. One of the frustrating limitations of traditional System Restore was that it was only reliably accessible when Windows could actually boot. If your machine was in a state where Windows couldn't start at all, getting to System Restore required navigating a somewhat unpredictable set of menus that didn't always appear or work consistently. Point-in-time restore is designed to be initiated through the Windows recovery environment. which is the dedicated recovery partition that ships on modern Windows 11 machines and is accessible even when the main operating system won't start. This means that even in the worst case scenario, where something has gone so wrong that your machine boots to a black screen or gets stuck in a restart loop, you can still access your restore points and bring the system back. The recovery path is trusted and consistent because it runs entirely outside of the broken main installation. Let's talk about the scenarios where this feature is designed to help, because understanding the intended use cases makes it much clearer why Microsoft built it the way they did. The most obvious scenario is the one everyone has experienced at some point. A Windows update installs and something stops working. Maybe a printer driver breaks. Maybe a network adapter behaves differently. Maybe a software application that worked perfectly before the update now crashes on startup. With point-in-time restore, if you have a restore point from before the update was applied, you can roll the entire machine back to that pre-update state, confirm that everything works again, and then decide whether to wait for a fixed version of the update before applying it again. This is the one-off device issue scenario that Microsoft specifically calls out as a design target for the feature. The second scenario is more significant for businesses and organizations managing multiple machines. Imagine a situation where a software deployment tool or group policy change or administrative script gets pushed out to a large number of machines simultaneously and causes a widespread problem. Perhaps it disables a security setting that breaks authentication. Perhaps it changes a network configuration that prevents machines from connecting to internal resources. In an organization with hundreds or thousands of machines, diagnosing and manually fixing this kind of problem machine by machine is enormously time-consuming and disruptive. Point-in-time restore is explicitly designed for exactly this kind of wider incident. Because the restore points are captured automatically and stored locally on each device, each affected machine can be rolled back independently to its pre-incident state without requiring network access to a central backup server and without requiring a technician to touch each machine individually. The recovery happens locally, quickly, and consistently across all the affected machines. The third scenario covers something that System Restore was never really designed to handle well: user or administrator-initiated changes that turn out to have unintended consequences. This could be something as simple as a user accidentally deleting a set of configuration files. It could be an administrator making a registry change that seemed correct based on available documentation, but turned out to break something unexpected. It could be an application installer that modifies shared system components and leaves other applications in a broken state. All of these are real common situations that IT departments and individual users encounter regularly. And all of them are scenarios where having a recent comprehensive snapshot of the system's working state available for quick restoration is enormously valuable. Now, let's get into the actual configuration of the feature, because this is where you, as a user or administrator, have meaningful control over how point-in-time restore behaves on your machine. The configuration is available within system settings in Windows 11, which makes it significantly more accessible than some of the older recovery tools that were buried in control panel menus most users never found. When you open the configuration, you will see options for controlling both the frequency of restore point captures and how long those restore points are retained before the system discards older ones to make space for newer captures. For restore point frequency, the default setting is every 24 hours, meaning the system captures a new snapshot of your machine once per day. If you want more granular recovery options and have the storage space to support it, you can set it to capture more frequently. The available options are 4 hours, 6 hours, 12 hours, 16 hours, and 24 hours. For a home user, the default 24-hour schedule is probably sufficient for most situations. For a business machine where changes happen frequently and rapid recovery is critical, a shorter capture interval might be worth the additional storage it requires. For restore point retention, the default is 72 hours, meaning the system keeps restore points for 3 days before the oldest ones start being discarded. The available options give you a range from 4 hours all the way up to 72 hours. Some of these retention options are only available in Enterprise editions of Windows 11, while the Standard Home and Pro editions have a subset of the available options. This tiered availability reflects the reality that the feature is designed to serve both individual home users and large business environments, and the enterprise-specific options are tailored to the more demanding recovery requirements that managed business environments typically have. The storage question is probably the most important practical consideration for most users thinking about whether to enable this feature and how to configure it. Point-in-time restore can use up to 50 gigabytes of storage on your drive, and Microsoft has been upfront about this number. The default allocation is 2% of your disk space with a minimum of 2 gigabytes. So on a machine with a reasonably sized modern drive, you're looking at a storage reservation somewhere between 2 gigabytes and 50 gigabytes, depending on your drive size and your configuration choices. The 50 gigabyte figure is the maximum cap, not the amount the feature will always use. On drives with less space available, it will use proportionally less, and you can also manually configure a lower storage allocation if you want to keep the feature enabled but limit its footprint. This storage requirement is genuinely the feature's most significant limitation for a meaningful portion of Windows users. Many people, particularly those with older laptops that shipped with smaller solid-state drives, are already running their primary drive close to capacity. If your C drive is nearly full, adding a feature that could reserve up to 50 gigabytes is simply not viable without first freeing up storage space or upgrading to a larger drive. The cost of solid-state drives has climbed in recent periods, which makes the storage upgrade option less attractive than it might have been previously. If you fall into the category of users who are consistently running low on drive space, point-in-time restore in its full configuration is not going to be practical for you without addressing the enable it, and set it to use a smaller storage allocation, which gives you some protection with less footprint. But the feature works best when it has sufficient space to maintain a meaningful history of restore points. For users who do have adequate storage, the process of actually using a restore point when something goes wrong is designed to be straightforward. If your machine is still able to boot into Windows normally, you can access the restore options through the system settings and initiate a rollback from there. The system will show you the available restore points, each with a timestamp, and you select the one you want to roll back to. The actual restoration process runs and brings the machine back to that state. And Microsoft describes this as being capable of restoring the entire system to a previous state in minutes, which represents a significant improvement over the kind of lengthy recovery processes that older backup and restore tools often required. If your machine cannot boot normally, the path into the restoration options runs through the Windows recovery environment. You can access this environment by interrupting the boot process in a specific way, which Windows 11 will typically prompt you to do automatically if it detects that normal boot has failed multiple times in a row. From within the recovery environment, you can navigate to the restore options and select a restore point to roll back to, and the restoration runs from that trusted environment rather than from within the broken main installation. It is worth comparing this directly to the classic system restore that Windows users have known for over 2 decades, because understanding the difference clarifies exactly what Microsoft has improved and why the improvement matters. System restore, while reliable within its scope, was limited in what it actually protected. It captured system files in registry state, but was never designed to fully capture installed applications, application configurations, or user files in the comprehensive way that point-in-time restore does. System restore also had a somewhat inconsistent track record with complex modern software environments, where deep interdependencies between applications, drivers, system components, and configuration files meant that a partial rollback sometimes left the machine in a state that was neither the old working configuration nor the new broken one, but some hybrid that required additional manual intervention to resolve. Point-in-time restore aims to avoid that problem by capturing a more complete picture of the system state and restoring it as a coherent whole. One aspect of this feature that deserves more attention than it typically gets in brief coverage is the way it handles the relationship between restore points and the changes that have happened since the most recent one was captured. When you initiate a restore, the speed and complexity of that restoration process depends significantly on how much has changed on the system since the restore point was taken. If you are rolling back to a snapshot captured only a few hours ago and relatively little has changed, the restoration is going to be faster and simpler than if you are rolling back to a snapshot from 48 hours ago on a machine that saw heavy use, multiple application installations, and several system configuration changes during that period. This is why the capture frequency setting matters in practice. A machine that captures restore points every 4 hours rather than every 24 hours gives you more granular rollback options and ensures that any given restore point you might use is closer to the current state of the machine, making the restoration both faster and more likely to land you in a state that feels recent rather than missing significant work or configuration that happened between the snapshot and the failure. For home users, setting up this feature for the first time, the practical recommendation is to leave the default settings in place initially and see how the storage usage develops on your specific machine. The default of a 20 ngtsa, 4-hour capture frequency, and 72-hour retention means you will typically have 2 or 3 restore points available at any given time, each representing a different point in the previous 3 days. That is a reasonable safety window for most home use cases. If you find that the feature is using more storage than you're comfortable with, you can reduce the storage allocation in the settings. If you want more granular protection and have the storage to support it, increasing the capture frequency gives you more restore points to choose from if something goes wrong. For IT administrators managing Windows 11 machines in a business environment, the enterprise-specific options give considerably more control over how the feature behaves across a managed fleet. The ability to set shorter capture frequencies and longer retention windows through enterprise policy means that administrators can ensure that the machines under their management always have a sufficient history of restore points, available to recover from even relatively long-running incidents. The integration with Windows management infrastructure also means that administrators do not have to configure this feature individually on each machine, which would be impractical at scale. There is also something worth saying about the psychological value of this kind of automated safety net. One of the reasons people are often reluctant to apply Windows updates promptly or to make configuration changes that might improve their system's performance or security is the fear that something will go wrong and they will be left with a broken machine and no easy way back. That fear is entirely rational given the history of how Windows updates have sometimes behaved. Point-in-time restore changes the risk calculation in a meaningful way. If you know that your machine is automatically maintaining a recent snapshot, you can roll back to within minutes. The prospect of applying a pending update or making a configuration change becomes considerably less anxiety-inducing. You have an exit ramp available if it doesn't go smoothly. That shift in the practical risk profile of routine system maintenance is one of the less discussed but genuinely important benefits of having this kind of recovery capability built into the operating system and running automatically. The verdict on point-in-time restore is that it represents a genuine and meaningful step forward for Windows recovery capabilities. System Restore served its purpose across many years and many Windows versions, but it was a product of a different era when Windows installations were simpler, applications were less deeply integrated with system components, and expectations for recovery speed were considerably less demanding. Point-in-time restore is designed for the Windows environment as it actually exists now, with complex application ecosystems, enterprise management requirements, and a user base that expects rapid, reliable recovery when things go wrong. The storage requirement is a real constraint that will limit the feature's usefulness for some users, but for anyone with adequate drive space, enabling it and leaving it running on the default schedule is one of the most practical things you can do to protect your machine against the kinds of disruptions that Windows updates, driver changes, and application installations can sometimes cause. Having a reliable, automatically maintained safety net running quietly in the background is exactly what modern Windows users have needed for a long time, and point-in-time restore delivers that in a way that System Restore was never quite able to.